Now for learning objective D, we're going to look at two problems. One will apply properties of nth roots to area and volume, the other to a rate. So we have a bowling game that cost 50 cents in 1960, and it might cost $3 in 2010. What is the annual growth rate? So remember, annual growth rate, hopefully you rings a bell from chapter 3, was the equation y equals a b to the x, or in more detail, y equals a 1 plus or minus r to the x power. And when we looked at this, the r here stood for the rate, either growth or decay. This 1 plus or minus r is the growth or decay factor, which also is what the b stands for. The a in both formulas stands for the initial starting amount, the y stands for the ending amount, and the x here in this case, and in this case, stands for time. So what do we know here? We know that the starting amount of a game was 50 cents, the ending amount was $3. And from that, we can see a time span that took place. It looks like we have a 50-year time span between 1960 to 2010. So why don't we just go ahead and we can put in $3 for our ending amount, 50 cents for our starting amount. I do not know the growth or decay rate or factor right here, but I do know the x, which is the time period, and I said it was 50 years. So to solve this for b, we absolutely can do that. First thing we're going to do is just divide both sides by the 0.5, and that's going to leave us with 6 equals b to the 50th power. To get rid of the 50 there, all you have to do is multiply by 1 over 50, which is its reciprocal. So what we're going to type in is see that b is equal to 6 to the 1/5 power. When you type that into the calculator, what you're going to get is it equals 1.036. Now, what we just found here was the actual b value. So the growth, I can tell by the way, because it's greater than 1, the growth factor is b. Well, this thing right here was also the growth factor. They mean the same thing. This formula to the right just gives us a little more detail. So if they ask you what is the growth rate, we can actually see the rate embedded in here. The rate in here, if we write it from a decimal to a percent, would actually end up being a 3.6% growth rate in the cost of bowling from 1960 to 2010. Now in this problem, we have the volume of a cone that has radius r, and its height is also equal to the radius. And we see that right here. We have a cone, here's the radius, and there's the height. And it is given by this formula here, volume equals 1/3 pi r cubed. Here's what they want us to do. Give a formula for the radius of this in terms of v. So they just want us to take this equation and solve it for radius. So all we have to do is the algebra to get r by itself. Now, one thing I can do is I can actually notice that 1 times pi is really just pi over 3. And to get rid of the fraction pi over 3, a really nice way to do is multiply by the reciprocal of 3 over pi. So I'm going to multiply by 3 over pi over here. That's going to leave me with 3v divided by pi, and that's going to be equal to r cubed. Now to get rid of the cubed, I can just raise this to the 1/3 power, and I would do the same thing over here. So that would leave us with the equation of r equals 3v over pi to the 1/3 power, or if I wanted to write it in radical format, I would do a cubed root of 3v over pi. Now, part B on this says, a cone with a radius of r and the height equal to its radius has the volume of 60. Use the formula from the part A to find its height. Well, the height of this cone is the actual radius, and we know that the volume here is 60. So all we need to do is take the volume of 60, put it into here, and simplify. So if we do that, the r, or in this case, the height, which is right there, is going to be 3 times 60 divided by pi, and we'll raise that to the 1/3 power. Be careful when you type this in your calculator. People will make a mistake right here. If you type it, what I would do is in parentheses do 3 times 60 and then divide it by pi. Then after you get that answer, you will raise the whole answer to the caret of 1/3. When you do that, you're going to get approximately 3.86, and units of measure on here would be millimeters.